So on this worksheet, you need to know what parallel lines are and what perpendicular lines are. And we still need to know how to write down equations in all three forms: standard, slope-intercept, and point-slope form. On the first section, they tell you to write an equation in slope-intercept form. So when they tell you slope-intercept form, you need to know what that looks like. Slope-intercept form looks like y equals mx plus b. So that's how you want to write your equation. So it'd be really easy if they gave you an m and a b. But the problem is they don't give you m and b. They give you a point, and they also give you a line, a different equation that's parallel to it. So they tell you that your line is going to be parallel to the equation that they give you. So indirectly, what they're saying is that your slope will be the same slope. So same slope. That's what parallel means, okay? So they give you a point, and they give you a line that's parallel to your line. So if I look at number 5, for example, they give me a point, and I have x1, y1, and they give me an equation that's parallel to the equation that I want. So when they tell me that it's parallel, I think same slope. So indirectly, wow, that's an ugly M. Let me erase it and rewrite it. Indirectly, they give us the slope of our line, okay? Our line has the slope 4/3 exactly like this equation over here. And I wish I had a b value, but I don't have a b value. I have a what? I already have my m, but besides the m, what do I have? I wish I had the b, because if I had my m and my b, I just plug it into slope-intercept form and I'm done. But I don't have a b. I have a point, an x1, y1. So if I have a point and I have a slope, what form is best? Point-slope, right? Even though they want it in slope-intercept, I mean, yeah, it'd be nice if I had a b value. Like if my b value were 5, then my equation would be y equals 4/3 x plus 5. But I don't have the b value, but I do have a point. So I have the slope indirectly given to us because they told us it's parallel, and I have a point. So what I'm going to do is plug it all into point-slope form. So there's my point-slope form equation. I recommend using blank spots before plugging in. So y minus blank spot equals blank spot for m, parenthesis x minus blank spot for the x1. Okay, so now let's plug in our values. My y1 value is up here on my x1, y1. My y1 value is 3, so that's going to be a 3 right there. So we put in the 3. And my m value is 4/3, so I put in the 4/3 right there. And my x1 value is 12. Of course, 12, I got it from the x1, and I plugged it in right there. So that's my point-slope form equation, but remember, they want it in slope-intercept form, not point-slope. They want y equals the mx plus b. So we want it to look like y equals mx plus b, not like y minus y1 equals m parentheses x minus x1. So what I need to do now is take this point-slope form equation and modify it to become slope-intercept. Are you with me? So obviously slope-intercept has y by itself. Right here we don't have y by itself. Slope-intercept doesn't have parentheses on the right side. Right here we have parentheses. So it's totally up to you. You could get rid of the fraction 4/3 by multiplying by 4, multiplying by 4, multiplying by 4. Or you could actually distribute the 4/3. 4/3 times x would be 4/3 x. 4/3 times 12, that would be 48 over 3, and that becomes 6, because 48 divided by 3 is 6. So either way, do you guys want to distribute the fraction or cancel out the fraction? Distribute? Okay, so let me zoom in and let me distribute the 4/3. So 4/3 times x, that's going to be 4/3 x. And then 4/3 times negative 12, that's going to be a negative, 4 times 12 is 48. 3 times 1 is 3. And we still have the equal sign. We still have the 3, the minus, and the y on this side. Let me zoom out a little so you can see the rest. So we almost have y by itself. Let's do this math right here. 48 divided by 3 is 16. Of course, you could use a calculator. So let me just scratch it out and put a 16 right next to it. So that's really a minus 16 right there. And I need to get rid of that minus 3 by adding 3 to get y by itself. So I'm going to add 3. So if I have a negative 16 plus 3, then I'm going to have the b value being negative 13. So my new equation will be y equals, because the negative 3 plus 3 cancels out, so you're going to have y equals 4/3 x minus 13, because 16 take away 3 is 13. So let me write that over here on the side. Y equals 4/3 x minus 13. If you check the answer on the back page, you'll see that that's correct. Now, it does get more fun. What do I mean by more fun? If we take a look at something like number 8, they give you a point and they tell you that your line is parallel to this line right here. Okay? So what does parallel mean? It means that it has the same slope. But the problem is you cannot see the slope of a standard form equation. So right here you have a standard form equation. You can't see the slope. The only way you could see the slope is if you change it to slope-intercept form to get y by itself. So what we're going to have to do is take this equation right here, the 3x minus y equals 5, and we're going to have to get the y by itself. So what do? Minus 3x. Minus 3x. My new equation is going to be negative y equals negative 3x plus 5. It's almost in y equals mx plus b form. The only other thing I need to do is multiply everything by negative 1. That way I'll get y equals positive 3x minus 5. And this is my slope-intercept form equation of that original equation that was given to us. And they tell us that that line is parallel to our line. So the only reason why I took this standard form equation and changed it to slope-intercept form is so that I could clearly see the slope of that equation. Are you with me? Yes. Now that I know the slope of that equation, I know that my equation has to be parallel to it, which means it has to have the same slope. So my equation is going to have the m equal to 3 also, the slope equal to 3 also. Okay? So I don't really need anything else over here. I just got the slope because I knew it was parallel, and that's all I need from it. I don't ever have to look at this stuff again. Now I could just focus in on making my equation with the slope that I just found and the point that they gave me. And we're going to do that by using what form? Point slope, of course. So point slope form is y minus y1 equals m parentheses x minus x1. Let's use blank spots to plug in our values. And of course the y1 value, here's x1, y1, that's negative 2. The m we just found out was 3, knowing that it was parallel to the other one. And then the x1 value is negative 1. So this is our point slope form equation. Just change the minus minus to plus plus. And we still need to change it to slope-intercept form. Now on the test, if I ask you to leave it in point slope form, then you would be done. But if I ask you to change it to slope-intercept, then you have to do some math. You have to get y by itself, and you have to get rid of those parentheses. So you're going to have to distribute. You're going to have to modify it. So if you distribute 3 times x, that's 3x. 3 times 1, that's 3. Bring down the equal sign, bring down the y, the plus, the 2. And all you need to do for your final step to get it in slope-intercept form is to get rid of that positive 2 by subtracting 2. What you do to one side, you do to the other side. So your final answer will be y equals 3x plus 1. That is your slope-intercept form equation of that problem. So that one was more entertaining. I didn't say more difficult, more entertaining, because when they tell you that your line is parallel to this one, the problem is that it's in standard form, so you don't know what the heck the slope is. Because when they say parallel, you need to think, oh, same slope. But you can't see the slope right here. So you have to change it with algebra to get the y by itself, so you could see y equals mx plus b. And then you could say, oh, now I could see the slope. The slope is 3. So my slope is also going to be 3. And then you realize, okay, now I have a slope, now I have some points, I use point-slope form, and then you change it to slope-intercept because that's the equation, the form of the equation they want your answer in. Okay. Now that's the first half. If you look down here at the second half, same concept. They give you a point, but instead of giving you an equation that's parallel, they give you an equation that's perpendicular. And that means opposite reciprocal slopes. Opposite reciprocal m values. Okay, opposite reciprocal m values. What does opposite reciprocal mean? It means to change sign and flip fraction. That's what it means. Change sign and flip fraction. That's what perpendicular lines are. They have an opposite reciprocal slope value. So we need to know that. Parallel, same exact slope. Perpendicular, opposite reciprocal slopes. You change the sign and flip the fraction. So it's pretty easy if you look at number 13. I'm not going to explain it because I already did on the previous video. The slope right here, it's really easy to see. This slope is negative 1/3. This slope is negative 1/3. So our slope would be, change the sign, flip the fraction. Our slope would be positive 3. Okay? Now, I already explained this one on a different video, so I'm not going to continue. But that's how you would get that slope, right? Now, the problem is, if you look at number 14, and I asked you, well, this equation, what's the slope of this equation? Could you see it yet? No, because it's in standard form, right? You need it in slope-intercept form, so you need to do some math first. So what would I have to do? Minus x, negative y equals negative x plus 5. So I still need to get the positive y instead of a negative y. So what would I do? Multiply everything by negative 1. I'd get y equals x minus 5. Are you with me? And now that it's in slope-intercept form, now I could see my slope value. What is my slope value right there? 1. Okay, my slope value is 1. So this equation, the only thing I want to get out of it is the slope, because my slope on the instructions say that it's going to be perpendicular to this slope. Okay, so what would my slope be? What would my m value be? Now, if they said parallel, well, then it would be 1. It would be exactly the same. So if they said, oh, your line will be parallel to this one, oh, so my slope would be 1. But they don't say it's parallel, they say it's perpendicular. So if they say perpendicular, what do I need to do to this slope? We just wrote it down in our notes. Change the sign and flip the fraction. So if you're like, wait, that's not fraction. Okay, you can make it look like a fraction. Go ahead and make it 1 over 1. And now when you change the sign, it's going to become negative. But when you flip this one and this one like that, it's still going to be 1 over 1. So our slope is negative 1 over 1. Okay? So now that we know our slope is negative 1 over 1, and now that we have a point that was given to us, we could plug it all into point-slope form. And of course, let's leave blank spots to plug it in. So let's plug in our values. Y is 5, x is negative 6, the m value is negative 1 over 1. I'm just going to put a negative 1. That's point-slope form. We want a slope-intercept form. So let's distribute the negative 1. It'll change those signs on the inside. First of all, before distributing, do minus minus, change it to plus plus. So you're really going to have the equation y minus 5 equals negative 1x minus 6. And final step would be to add 5 to both sides. So you get y equals negative x minus 1. And that's your slope-intercept form equation. So I hope this helps. I'm actually not going to post this one on Edmodo. This is just going to be on the YouTube channel. But the ones I did post on Edmodo, those are more geared towards the questions that you're going to see on the test. So make sure you watch those. And if you don't have access to Edmodo, just watch the videos from yesterday.